In this video, we will discuss the difference between speed and velocity, average speed and average velocity, and also their units. We have already seen in the previous video that distance is always greater than or equal to magnitude of displacement. Displacement magnitude. Here, speed is defined as the distance traveled by the object in a unit time, and velocity is defined as displacement of the object in a unit time. In a unit time, in the sense, suppose you have 20 chocolates and 10 persons. For 10 persons, 20 chocolates, then for 1 person, 2 chocolate. How did we get that? We have to divide by number of persons. Similarly, in t seconds, an object traveled t distance, t meter distance, then for 1 second it is t by t. So the same way, like 10 persons, 20 chocolate, then for 1 person divided by number of person, you will get that. The same way, the distance traveled by the object in 1 second, in order to find that, you have to divide the distance by time. So here we define speed as distance by time. Distance is in SI system, it is measured in meter. In CJ system, it is measured in centimeter, or in common units we measure it in kilometers, or in other countries like the US, UK, they measure it in miles. But time is usually measured in seconds in SI system. In CJ system also it is in seconds, or in a common unit we use hours. So the unit of speed is actually any unit of distance by any unit of time. So the units of speed could be meter per second, or centimeter per second, or kilometer per second, or kilometer per hour, or miles per hour, which these two things we commonly come across. So this is often abbreviated in our speedometers of the bike as kmph, kilometer per hour. If you were to buy a car or something in the US or UK, so that will be graduated. The speedometers there would be graduated in miles per hour. It will be mentioned as mph. So these are the common units of speed. So displacement, on the other hand, which is also measured in meter in SI system, centimeter in SI system, CGS system, kilometer in common system, the units of both distance and displacements are the same. Hence, the units of speed and velocities are the same. So because velocity is defined as displacement by time. The same way, all these units holds together, because meter per second, centimeter per second, kilometer per second, kilometer per hour. So any unit of distance to any unit of time is often the unit of speed or velocity. So then what is the difference, or what is the relation between speed and velocity? Because speed is defined as distance by time, velocity is, suppose you write like this, speed and velocity. They both have the same units, and these two are not same. So this is a scalar. Speed is a scalar because it is distance by time. Velocity is a vector because it is displacement by time. Because displacement is a vector, velocity is a vector. Because velocity is defined as displacement by time. That means displacement per unit time. In other words, for 1 second, how much is the displacement? That is called velocity. But speed is defined as distance by time. That means for every 1 second, how much distance it covers is called speed. For every 1 second, how much displacement is taking place, that is called velocity. But since these two are two different quantities, this is a vector, this is a scalar, you can't directly compare this. But when you take magnitude, The magnitude of displacement by time has got only the value because the magnitude means we are taking away the direction. Then this value is often less than or equal to distance by time, because distance is always greater than or equal to displacement. Hence, distance by time is always greater than or equal to displacement by time, and hence speed is often greater than or equal to magnitude of velocity. So directly you should not say speed is always greater than or equal to velocity. You should say speed is always greater than or equal to magnitude of velocity. Suppose when we travel from one town to another town, we don't go with the same speed. Suppose if you take your bike, in the bike there is a meter and that needle will move through the meter. So that one is called speedometer, but inside the speedometer there will be some small wheels that is showing the numbers. So far how many kilometers you have traveled in your bike, that is called odometer. So the speedometer, as you speed up in your bike, that shows the instantaneous speed. Suppose you are traveling from one town to another town, you are accelerating. Whenever the traffic is much, then you need to slow down so that your speedometer will show a lesser value. Whenever there is no one and the roads are clean, then you move faster. That time your speedometer shows a greater value. So when you travel, you don't go with the same speed. At different points in space, you will be going with different speeds. That is called instantaneous speed. Related to instantaneous speed, you can also find instantaneous velocity. But there is the other quantity called average speed and average velocity. Let us look at this case. There is the same fashion which we took. There is a town A, there is another town B, and you are going to town A to B this way. The length of this road, the total length of this road, let us say 30 kilometers. But this town B from A, suppose this is a graph and this is east, this is north, and this, if this is north, this is south, and this is west. In the map, if you say this, the town B is between, this is north, this is east, this is northeast. So from A, this B lies in a direction northeast. If you connect it with a straight line, supposing this is coming out to be 20 kilometers. Let us say this is a case. So in the map, town B is at a distance of 20 kilometers northeast. Then you are talking about displacement, right? So if you move from town A to B in 1 hour, in 2 hours, let us say you are going by some other very slow electric bike, you take 2 hours to go from town A to town B. Though at different points of this track you will be going with different speeds, but overall you took 2 hours. So the average speed in this case is the total distance covered by time taken. The total distance covered is 30 kilometers and the time taken is 2 hours. Then the average speed is 15 kilometer per hour. Then look at velocity, average velocity. The average velocity here stands for total displacement by total time taken. The total, suppose the total displacement here is mentioned as 20 kilometers, that it took when he started from A to reach B, totally he took 2 hours. So for this displacement, it has taken 2 hours. So here 20 kilometers of displacement is covered in 2 hours, which means that it is 10 kilometer per hour. So the average speed is 15 kilometer per hour, average velocity is 10 kilometer per hour. But here I have not mentioned the direction, so it is not average velocity, it is magnitude of average velocity. Then what is velocity, average velocity? Then you have to mention this 10 kilometers per hour northeast. That means you are adding the direction to this. Now this really means velocity, the average velocity. This is how you calculate average speed and average velocities.